Okay, so hi everyone. So welcome back to this new video in the CSES problem set. So today in this video we are going to solve this problem from sliding window section that goes by the name sliding window mode. So let us start with this problem now. So the problem reads like this, that you are given an array of n integers and your task is to calculate the mode of each window of k elements from left to right. So here the definition of mode is given. So the mode is the most frequent element in an array. And it is also told us that if there are several possible modes, then we have to choose the smallest out of them, right? So keep this in mind because this is a very important information. Then in the input we will be given with two integers, that is n and k, which will represent the number of elements and the size of each window. And then we are also given with n integers representing the content of the array. So in the output we have to print n minus k plus 1 values, that is the mode for each window. And since the total number of windows will be equal to n minus k plus 1, that's why we have to print a total of n minus k plus 1 values. And this is a constraint here in which k and n can go up till 2 into 10 to the power 5, and the value of each element can be as high as 1e9. So this is the problem, and here is an example given. So this is the given input and this is the expected output here, right? So this is the overall question. So the question is asking us a simple thing, that for each window of size k we have to print the mode, that is the most frequent element in that window. And if there are several elements which have the maximum mode, then we have to choose the smallest of them. So let us try to understand this problem with this given example only in much detail. So this is the example given to you in the problem, right, in which the value of n is 8, that is a total of 8 elements are present, that is from 1 till this, right, and the window size is 3. So if I write here, then the value of n is 8 and k is equal to 3. Since I want to use one based indexing, so that's why what I have done is I have considered a dummy value here at the 0th index, in the same way as I have done in previous problems. And we also know that the total number of windows is n minus k plus 1, that is 8 minus 3 plus 1, which is 6. So a total of 6 windows will be present in this given example. And here for each window that I have marked with a different color, these are the expected outputs written on the top of it. So since this will be our first window of size 3, so for this window the expected output should be 1. Similarly for this second window that I have marked with the blue color, the expected output is 2, and so on for every 6 windows here. So this is the overall problem. I hope you got it, and this is the given example and the expected outputs of it. So let us now see how we will approach this problem. Before moving ahead, it should be very clear to you that what is mode exactly. So you might have studied it in your earlier classes. So let's see its definition. So mode is nothing but the most frequent element. So if you are asked to find the mode of a range, then it means that you simply have to return that element which is most frequent in that range, right? So it simply means this, nothing else. So since it is talking about the frequency of an element, that is the most frequent element, that is the element with the maximum frequency in that range. So it means that here we are going to deal with the frequency of every element, right? So what I am saying is, so in order to find the mode, the frequency of elements must be tracked continuously, right? Because now we know that we want the mode, and mode is nothing but the most frequent element, right? So we want to know the frequency for each and every element, and then only we will be able to decide that which element has the maximum frequency. And in order to do that, map can help us very easily, right? So that's why we will use a map in order to keep a track of count or frequency of every element of the current window, right? So that's why we will use a map which will help us in order to give the information of the current window, that which element is present how many times in the current window. But is this information sufficient in order to calculate the mode? I don't think so, because this map will only be helping us in order to determine that which element is occurring how many times, right? But what we want that element with the maximum frequency. So that's why what I will do is, along with using this map, I will also use a set. Why? Let's read it. So now suppose we know the frequency of each element in the current window using the map, then out of all those elements we want that element which has the maximum frequency, and we want to retrieve that element, right? And in order to do this we will use a set. Why? Because we know that a set is sorted, because by default a set is an ordered set, so it is sorted. And if it will be sorted, then we know that at the front of set the smallest element will be present, right? And so the smallest element will be present at the start of the set, and similarly the largest element will be present at the end of this set. So if someone wants to retrieve the smallest value of the set, or the range, or the largest value of the range, then he or she only needs to deal with the extreme points of this set, that is either the front part of it or either the end part of it, in order to retrieve the smallest and largest element respectively, thereby making it easier for us to retrieve the smallest and largest values, right? So that's why we need to use a set here, so that we'll be able to retrieve the element with the maximum frequency present in the map, right? So that's why in this problem we'll be using map along with this set. So once this thing is clear, let us move forward and let us start operating with our windows here, right? So let's see what this picture describes here. As we know that this will be our very first window, so what we will do is we will handle this window here separately, and after this window is done, the information that it will generate, we will use it in the next windows, right? So since this is the first window and we have no information in the set or map, so that's why we need to compute it from the very start. Let us start here. We know that we need to build our first window, right? In order to do this, we know what we can do. We will start our iteration from 1th index to the kth index. Let us do that and see how we will proceed with our approach. So suppose we started our iteration and we are at the first index. So we will see that at the first index the value of element is 1. So it means that this one element is present in our current window, and since it is present in our current window, it means that the count of this one must be increased by 1, right? So that's why in the map what I will do is, for 1 I will increase the count of 1 by 1, because we have encountered it just 1 as of now. So here what I will do is, in the map I will set 1 nums of I to frequency equal to 1, right? So if you are worried that why I have written here -1, then I want you to wait for 2 or 3 minutes and then you will realize why I have done this. But as of now, just assume that here I have written a 1 and here 1 also, that is frequency of 1 is 1, right? So once we do this, then we will see that if this 1 is present in the set or not. So since we are inserting this 1 for the first time in the map, so we know that this 1 is not present in the set. So what we will do is, since we want the frequency to be present at the front and the element of that frequency at the second part of the pair, so that's why we will push the frequency and then the element as a pair in this set, right? So that's why here, since I have encountered 1, so I will push the frequency of 1 here, which is 1, and the element itself 1, that is 1, 1. So I will push it in the set. But here I have pushed it 1 and then -1 and not just a +1. So as I have told you that just wait for a minute and you will realize why I have inserted a negative value of the original, right? So suppose I have inserted this now, right? And then our window size will increase. So now we will encounter the second element having a value of 2. So again in the map I will do a MP of 2 plus plus, right? So here I have done a -2. So once MP of 2 plus plus will be done, again I will check if it is present in the set or not. So since this 2 is not present in the set as of now, so again, because as of now only this is present, right? And these two are not present. So again I will push a pair in the set, first denoting the frequency of the current element and then the element. So here I will push a 1, 2, let's say. So I have inserted this 1, 2 in the set, and now again the window size will increase, right? And finally we will reach the last element of this window. So again what we will do, we will do a MP of 3 plus plus, because the count of 3 must be increased by 1, right? So the count of 3 should be equal to 1 now, and again we will check if this 3 is present in the set or not. So since this 3 is not present, so again I will insert a frequency and the element, that is 1, 3 into the set. And once I have pushed all those elements in the set, since we know that a set is nothing but a ordered data structure, so it will rearrange itself in order to get ordered, right? So it will rearrange itself so that it becomes completely ordered. That is, the smallest element should be present at the beginning and the largest element should be present at the end, right? So suppose this has happened. So whatever I told you, it will result into this set here. So it will result into this set, right? That is, the frequency of 1, 2 and 3 is equal to 1, 1 each, and that's why they are present in the set like this. That is, the frequency of 1 is 1, the frequency of 2 is 1, and the frequency of 3 is 1. So once this set is determined for the current window, now we want to print the mode of this current window. So what is mode? Mode is the most frequent element, and we know that in this set the first element of every pair denotes the frequency, and we want the maximum frequency, that is the mode. So the maximum frequency will be present at the end, right? Because this set is sorted by default, right? So we will come to this last element having the maximum frequency, and then we will see what is the element here. So here it is equal to 3. So that's why what it will do is it will simply print 3. But is it true? No, because in the question it was written that whenever the maximum frequency will be equal for greater than one element, that is 2 or more elements, then we have to choose the smallest of them. So since here all these 3 elements present in the set are having an equal frequency equal to 1, then it means that out of all these 3 we have to choose the smallest element. That is, we need to choose this one here which is present at the beginning, right? So theoretically we knew that in a set the elements will be present in sorted form, so that's why our element with the maximum frequency will be present at the last. So in that way we'll just print that element. But here this is not the case. As you can see that since the frequency of all the elements are equal, so we need to print that element having the smallest value, which is this one. But the problem do not ends here, because suppose instead of this set, the set resulted into this, let's say. That is, the frequency of 1 was 1, the frequency of 6 is 2, and the frequency of 5 is 3, right? So this is the most ideal condition that you can imagine in your mind. That is, the set is ordered and the elements frequency is increasing in this direction, and the element with the maximum frequency is this 5. So we'll just print a 5 using this begin, right? So this is what we wanted to have. But since in the question this extra condition is given that whenever the mode will be same, that is the maximum frequency will be same for 2 or more elements, then we have to print the smallest of them. So this is creating a problem here. So the same problem can be seen here also, that the frequency of 1 is 1, the frequency of 7 is 3, and the frequency of 5 is 3. So here in this direction the frequency will definitely increase, right? Here it is 1, then here it is 3, and then here it is also 3. But the maximum frequency is 3 and it is for both of these elements, right? I think I have done a small mistake here. Let me correct it. So it will be present here and it will be present here because this is an ordered set, right? Okay. So what I am saying is the frequency is increasing in this direction. The frequency of this 1 is 1. The frequency of this 5 is 3 and the frequency of this 7 is 3. So again, the maximum frequency is of these two elements. And according to the question, we need to print the element having the minimum value. So out of these two, that is 5 and 7, 5 is less than 7. So we need to print a 5 here, which is neither the begin nor the R begin in this set, right? I hope you are able to understand what problem is happening here. So because of this extra condition given that whenever the maximum frequency will be same for 2 or more elements, we need to print the element with the least value. We are not able to use this last element that we thought would be of use when the elements would be in sorted order, right? Because even when the elements are in sorted order, we are not able to use this R begin because we need the element with the smallest value. So that's why what we will do in order to solve this problem is we will use the negative value of every element given, and using that every time we will be able to use the last element of the set as the most frequent element easily, right? So this is a common maths actually, nothing fancy. So the same thing here I have done here for the first window if you see. So since the elements were 1, 2 and 3, so what I have done is I have stored -1, -2 and -3 for each one of them, right, having a frequency of 1. And as I moved forward, so initially our window was this, then we increased the count of the map by 1, that is MP of -1 and then inserted the same in the set. That is, I inserted 1, -1, that is this element, and then again I increased the size of the window. So again I increased the count of this -2 actually in the map, that is MP of -2 and then again I inserted this into the set, that is 1, -2. And once this is also done, I again moved forward and encountered 3, which is actually -3 now. So MP of -3 and then I inserted this 1, -3 into the set. So once I have inserted these 3 values in the set like this, it will rearrange itself. And after rearranging, this will be my ordered set finally. So now you can see clearly that since this is an ordered set, so the frequency must increase in this direction, right? But since here the frequency of each and every element is equal to 1, so the frequency of this -3 is 1, the frequency of -2 is 1, the frequency of -1 is also 1. and since the frequency are all equal, then the elements are sorted based on the values of the second element, that is -3, -2 and -1. So this -3, -2 and -1 is also increasing in this direction, that is sorted, which should be the property of this set, right? So that's why now if someone asks you for the mode, then what you will do is you will simply go to this last element of this set, and we know that the element value is this and the frequency value is this. So since we want the element value, so we will just take this. So what is this? It is -1. But since we know that the mode for each window will be positive because every integer given in the input is a positive one, so what we will do is we will simply take the negative of this, that is negative of -1, which is just 1, and that will be our correct mode for the current window, right? That is 1. So that's in the expected output here also. The expected output for the first window is 1. So that's why it was very important here to take the negative value of each element in order to get the correct mode according to this logic. So once this is done, let us move forward now. I hope this thing is clear, and let's see how this will work for the remaining windows as well, right? So once the first window is handled separately, we will deal with the remaining windows. So this will be our second window now, right? So earlier the window was like this, and now we want to add the contribution of this nums of I, that is 2, and want to decrease the contribution of this nums of I minus k, that is 1. So now we know that since this is 2 here, so this is not 2, this is actually -2 in our case. So what I will do is, so I will say that MP of this -2 plus plus, because this is coming in our window. So earlier the count of -2 was 1, now the count of -2 will become 2, and since this 1 is getting excluded, so earlier the count of -1 was 1, then it will decrease now, so the count of -1 will become equal to 0. We know that these two elements here, that is nums of I and this nums of I minus k, their count are modified in this map. And since their counts are modified in this map, so it means that they need to be reinserted into the set with the correct count. So that's why whatever pair was present for this 2 and 1 before, we need to erase it from the set and reinsert it with the correct count, that is the correct frequency. So since earlier for -1 the value was 1 and for -2 the value was 1, so what we did, we simply erased those two pairs and again reinserted it with the correct value, that is -1 0 and then -2 2. So earlier the element was -1 and its frequency was 1, but since -1 frequency has now become equal to 0, so we simply erased that pair and again inserted it, but with a value of 0 this time. Similarly, since earlier the count of -2 was 1, but since now it has become equal to 2, so that's why I simply erased this pair and reinserted it with the correct count, that is -2, 2. So now for this current window, that is the second window, this is my updated set. So it will rearrange itself in order to get ordered, and after getting reordered, this will be the final set, that is the elements value should increase in this direction. So since the first element represents the frequency, so it is increasing, as you can see. First it is 0, then 1, then 2. So all the frequencies are distinct, and since we want the maximum frequency element, so that's why we will directly jump into the last element using this r_begin term, right? And we will check what element it is. So it is -2, so we will just take a negative of that, and that will give us 2, right, which is our correct mode for this second window. And here you can see also that this 2 is appearing 2 times and 3 is appearing 1 time. So obviously this 2 is our mode, so we will just print a 2, and in this way we are able to use this r_begin term and not any intermediary. So in this way our second window is also handled peacefully. Let us now move to the third window, right? So this will be our third window. So before the status was this, and now 5 is getting added and 2 was getting removed, right? So since 5 is getting added, so we will do a MP of 5 plus plus, which is actually MP of -5 plus plus, and a MP of -2 minus minus, right? So it will result into this map, and since the condition or since the count of this 5 and this 2 has changed now in the map, so that's why for the updated map, I will create an updated set here. So since earlier 5 was not present in the set at all, if you see, so it means that I will fresh insert this -5 into the set. That is the count and the element, that is 1, -5. So it is inserted for the first time here. But since this 2 was present before, which is actually -2 with a count of 2, which is now decreased by 1. So I simply erased this and reinserted it with the correct value, which is 1. That is 1 comma minus 2, which is inserted here like this. So once these two values are inserted and these two values will remain as it is, that is 0 comma minus 1 and 1 comma minus 3. So these two values will remain as it is, right? So once these two values are inserted here, this set will now rearrange itself to become ordered, right? And once it is ordered, it will look like this. That is, the elements will increase in this direction, right? So the frequency of this first element is 0, then 1, then again 1, then again 1, right? So clearly there are 3 elements having a maximum frequency equal to 1, and out of them, since we want the smallest of them, so that's why if we just go to the last element, which is r begin, and take a negative of it, so it will give us 2. So it will be the smallest among them. But if you had not used that negative concept, then this 1 comma minus 2 would have been actually present here, and then it would have been difficult for us to retrieve it. But using this negative logic, this minimum element will be always present at the end, and that's why we just have to take a negative of it in order to get the correct answer for the window. So once this is clear, let us move to our fourth window, right? So this will be our fourth window, and in this you can see that earlier this was the status of the window, and now nums of I, which is equal to 2, was added, and nums of I minus k equal to 3 was removed, right? So the MP of minus 2 should be plus plus here, and MP of minus 3 should be minus minus. So since here earlier MP of minus 2 was 1, so now it will get increased by 1, so MP of minus 2 will be 2 now. And since earlier MP of minus 3 was 1, and here it is decreasing, so MP of minus 3 will become equal to 0 now. So this is my updated map, and since the count of these 2 and 3 is changed in this map, so that's why what we'll do is, in the previous set we will erase the pair of this 2 and 3, right? That is, we will erase this and this. So 0 comma minus 1 and 1 comma minus 5 will remain as it is like this, and again we will reinsert it with the modified count, that is this and this, that is 2 comma minus 2 and 0 comma minus 3. So 2 comma minus 2 and 0 comma minus 3. So we will reinsert it, and after reinserting it, this set will rearrange itself in order to get ordered. And once this is ordered, in order to get the mode, we will simply go to the last element and we will see its value. So since here it is minus 2, so we will take a negative of it, which is equal to 2, and that will be our correct answer. So in this window you can also see that 2 is occurring 2 times, so that's why this is the mode here. So in this way our fourth window will be completed, and then we will move to the fifth window, that is the last second window, and here this 4 is getting added and this 2 is getting removed. So since in the previous window there was no 4 present in the map, so it means that a new field for this minus 4 will be created here. So MP of minus 4 plus plus, and since this 2 is getting excluded, so earlier MP of minus 2 was 2, so now it should be equal to 1, so minus 2 is turned to 1. So that's why this is my updated map now, and since the map is updated, it means that the count with which the set was present before should also be updated now. So since this 4 and this 2 was getting modified and this 4 is added for the first time, so I will add this 4 into the set as 1 comma minus 4 here. And since this 2 is also modified here, so earlier it was 2 comma minus 2, right? But now it should be what? It should be 1 comma minus 2. So I will reinsert it like this. So once both of these two elements are reinserted, and these 3 will remain same, right? That is 0 minus 3, 0 minus 1, 1 minus 5, 0 minus 1, 0 minus 3, 1 minus 5. So these 3 will remain same, and only these 2 need to be reinserted after deleting it from the previous set. So once this is done, this set will rearrange itself to get ordered, and once this is ordered, we know that the elements will be ordered based on the frequency and then the element's value. So the frequency is increasing in this direction. It is having a frequency of 0, then these 3 are having a frequency of 1. So out of all these 3, since we want the element with the minimum value, so it is present at the last, so we just need to take the negative of it, which will give us 2. And it is also visible in this window that all these elements are having a frequency of 1, and the smallest of them is this 2. So that's why we are correct in this logic till now. And finally we will move to our last window, that is the sixth window. So here this is the sixth window, right? And in this the fourth element is getting added and this 5 is getting removed. That is, we will say a MP of minus 4 plus plus again. That is, the count will get increased from 1 to this 2 here, and similarly the 5 is getting excluded. So since earlier -5 count was 1, so now it will get 0 like this. So these two are modified, and since these two are modified, so what we will do is we will go to the set here which is present as of now, and we will erase the count of this -4 and -5. That is, we will erase these two and only these three will remain. That is 0 -3, 0 -1 and 1 -2. So 0 -3, 0 -1 and 1 -2 will remain as it is, and we will reinsert the updated values for both of these. That is 0 -5 and 2 -4. So 0 -5 and 2 -4 we will reinsert it, and after reinserting it the set will rearrange itself to get ordered. And once this is ordered, we know the elements will be present in increasing order. That is, the frequency will increase in this direction. And since we want the element with the maximum frequency, so it means that it will definitely be present at the end, right? So it is here actually and not there. So the element with the maximum frequency will be present at the end. So if you look, then it is equal to -4. So just take a negative of it. So it is equal to 4. So we can say that for this current window, the element with the maximum frequency is 4, which is clearly visible here also. So that's why the expected output is also 4 here. So in this way, all the 6 windows are completed successfully. So what we printed? So first we printed 1, then 2, then 2, then 2, then 2, then 4. Right. So this is our final answer. And also if you look in the expected output in the question problem statement, then it is same here. That is 1, then 4 2s, then just a 4. Right. So we also did the same. That is first 1, then 4 2s. So this is the first 2, second 2, third 2, fourth 2, and then finally 4. So now let us see the code here without wasting any further time. So this will be our code. So first we will take the input of this n and k, and then we will take the input of the array in one base type. Then I will declare or initialize this map and set, and this set will be a pair of pairs. So the first int will represent the frequency and the second int will represent the element. So we'll deal with the first window here, that is from 1 to k we will travel, and for each element we will treat it as a negative value, right? So this is my current element, and so I will check if it is present in the set or not. So if it is present, then I will erase it from the set. Then I will increase its count by 1 in the map, and then I will reinsert it with the updated value here. And after the first window is done, whatever element is present at the end, we will simply take its second value and take a negative of it in order to get the correct mode. And once the first window is done, we will handle the remaining windows in a similar way. So this nums of I will be this next element, and nums of I minus k will be this previous element. So since we know that the count of both this next element and previous element will be manipulated now, so whatever information the set contains for these two elements, we will simply erase them, and simultaneously I will also increase the count of them. And once they are erased and the map value is updated, I will reinsert it into the set with the updated count. And once they are reinserted, the set will reorder itself in order to get sorted, and then I will simply go to the last element second value and take a negative of it in order to get the correct mode for the correct window. And in this way all the n minus k plus 1 windows will be handled. So this is the overall code and logic. So I hope that you understood everything very correctly. So if you like the video, please consider subscribing the channel, as it takes me a lot of efforts to create every single video every single day. So please support me, and thank you so much for watching these videos. Thank you.